How does your iPhone use your face to keep your phone secure? How does it tell the difference between your face and someone else's? There's no way to match every pixel of an image to your face. What about lighting changes or makeup? Turns out Face ID uses a 3D model of your face for authentication. But how does it work when you're wearing glasses or a scarf? Though the technology is kept somewhat secret for security reasons, it's safe to assume that deep learning neural networks are what drives Face ID. It learns across multiple scans what your face looks like and can infer that it's you even if you're wearing a new, somewhat obstructive piece of clothing. In fact, this kind of adaptivity is becoming more prevalent in current technology as neural networks and machine learning are being adopted in other industries. Everything from medicine to transportation. So what is a neural network anyways? A neural network is, simply put, a model of a brain run on a computer. It's represented by nodes and connections similar to neurons and synapses in the human brain. They take input, pass it through a function that becomes more complex as more nodes are added, and spit out an answer. The thing that makes them so useful is that this function is finely tuned by hundreds or thousands of different precise weights. These weights are adjusted to produce more desirable output, and the cost function is what tells the network how much to change. A cost function is a way of representing how close the neural network is to the correct answer, usually provided by the humans training it. After the neural network is trained with existing data, it can be used to make conclusions with new data. So what are some of the applications of this technology? Because of the scalable nature of neural networks, they excel at taking in a large amount of inputs and making sense of them in a predictive manner. As a result, they seem perfect for medical diagnosis. This is an area filled with unknown variables and factors that share relation yet are hard to correlate by hand. For example, heart rate, blood pressure, breathing rate, age, sex, activity level, and tons of other factors affect a patient's diagnosis for heart disease, but it's difficult to assess someone's health by taking these all into account together. This is where the neural network comes in. With the correct model, determining whether a patient is diagnosed with a medical ailment or not is as simple as calculating the magnitude of the distance between their output and their healthy output. However, challenges do exist with this method of diagnosis, the most glaring of which is the compilation of the data set to train the model with. Training a network takes thousands of input sets, which would be very challenging to acquire since this model would use information from real people. With all these benefits, it seems like everyone should be supporting research in artificial intelligence, right? Well, not quite. One of the more controversial uses of neural networks is self-driving cars. You may hear in the news about companies like Google and Uber researching and testing fully autonomous cars on the road and the logistics of widespread adoption of these cars. But before we get into that, let's talk about how they work. To put it simply, these cars combine a series of sensors and lasers to map out the environment. The inputs from the map are then processed by a neural network to produce instructions for controlling the car. Some benefits this technology brings include enabling people who don't have the ability to drive to have access to their own transportation, and hypothetically reducing the number of driving errors caused by humans. According to the National Highway Traffic and Safety Administration, 94% of car crashes are a result of human error. But looking on the other side, self-driving cars would also introduce several new problems. How would companies ensure cybersecurity and prevent cars from being remotely accessed? What about harmful emissions now that the barrier for driving is lower? Or the classic trolley problem. How would a car decide between running into a group of people or letting the driver get into a deadly crash? These questions still need to be addressed before self-driving cars can be widely adopted. So, besides unlocking your phone, how could neural networks be used to improve your day-to-day life?